Okay, it's that time of week again. Our assignment for this week is a Gantt chart. We've finished the network diagram. I think some of you have got some work to do to make revisions in your network diagram before beginning the Gantt chart. But what I'd like to do is to go over the Gantt chart and some of the concepts that are associated with it. On the screen here, you can see I have a very simple project. I have a few reservations here. Let me explain those very quickly. First of all, over here on the left, this is not a work breakdown structure. Okay, there's nothing broken down here. You know, a work breakdown structure has multiple levels, starting with the project, the sub-projects, several layers of sub-projects, and then finally work packages. Essentially what we have here are work packages, but these are way too broad. They don't meet any of our guidelines and they need to be broken down further. But the purpose of this Gantt chart is to illustrate some principles. So let's not pay too much attention to the work breakdown structure. I've got a couple of other examples here that show what a work breakdown structure would look like in a Gantt chart. Let me just bring up one of those. Let's try this one. This is a project that one of my clients did within the last year or two. And I did a little bit of consulting with him to help him work out some of the problems with the work breakdown structure and the schedule itself. This is a first draft, so that it still needs some work. But you'll notice that we have sub-projects and then we have work packages here. And remember, only the work packages are scheduled. They have duration. One of the things you'll notice about this is that there's an awful lot of red. Red is traditionally the color of the critical path. So it's very easy to see where the critical path is. One of the nice things about using software like Microsoft Project, I happen to be using Merlin here, but regardless of which software you're using, it's very easy to switch from the Gantt view to a network diagram, and there you can see where the critical activities are. There are a few problems with this, and I'm not going to go into any detail here. I just wanted to show you what a work breakdown structure would look like in a Gantt chart. Here's another one. This is in fact one that I did myself for a film festival. And here again you can see that we can look at it at different levels. Go to level 2 and I can go a few more levels, but you get the idea. Let's go back to our original example here, the manufacturing example. Okay, the critical path is across the top. It's the one in red. What makes it the critical path? Well, the critical path is the longest path. And if we look at here, you know, when I'm doing workshops, I show this example and I ask people, how many paths are there here? And usually the response I get is 2 or 3. There are actually 4. There's one that goes across the top here, like that. There's another one that goes across the bottom, so that's 2 paths. And then the third path comes down this way, across here, up here, and down. And then the fourth one comes this way, here, up here. Now the critical path, if you add up the durations, is 28 weeks. The path along the bottom is 18, and the two in the middle are 22 and 24 weeks respectively. So the top is the critical path because it is simply the longest path. Now we introduced the concept of slack or float. I usually use the term float, but excuse me, I usually use the term slack, but float was used in the templates. So I tried to use the word float in the comments that I wrote to you, but either way, it's the same thing. The the float or slack is the difference between the length of the critical path and the length of the other paths. So for example, right here, this path is 18 weeks long. The critical path is 28 weeks. So this gives us 10 weeks of slack here. And likewise, we have slack here and we have slack here. Now, one thing we should remember is that slack is a resource. It gives us flexibility in scheduling. So for example, this activity right here is produce TV ad. It's scheduled to take 8 weeks. What happens if it takes 10? Well, we use up 2 weeks of slack, but it doesn't delay the completion of the project. And likewise, along here, we have slack that we could use if these things don't finish on time. Now, that doesn't mean that we shouldn't finish activities on time, but it simply means that let's suppose that manufacturing was not going well and we needed to divert resources. Perhaps some of the people who are working on the TV ad, now this may be a little far-fetched in this example, but you can divert resources from non-critical activities to critical activities to help shorten the duration. It will make the non-critical activity take longer, but it just uses up a little bit of slack. If any activity on the critical path does not finish on time, it potentially delays the completion of the project. So if the prototype takes 7 weeks, then we have to take 1 week out of manufacturing, assembly, and delivery. Not out of each one, but collectively. Okay? Otherwise, the project finishes 1 week late. So when we're managing a project, it's extremely important to pay attention to the critical path. You know, in my consulting work, I'm amazed at how many organizations manage a project without knowing where the critical path is. So as a project manager, these are the activities that I need to make sure finish on time because they're the ones that potentially will delay the completion of the project. Now that doesn't mean I ignore the others, but simply I have a little bit of leeway there because there's slack in case some of those activities would take a little bit longer than anticipated. So this is essentially a network diagram with a calendar across the top. If you look at the network diagram, all this does is it tells us the order in which things take place. There's no dates here. It's not designed to do that, but simply to show the flow of the project. And simply because this activity and this activity are lined up doesn't mean they're being done at the same time. It's just simply a matter of convention. It looks nice when they're all lined up nice and neatly, but it has nothing to do with when the work actually gets done. That's what the network diagram does, is it shows us. Now, for a schedule, we need 3 things. One is we need a start date, and secondly, we need to know the sequence of events. We got that from the network diagram. And then lastly, we need to know the duration of each activity. Now remember, work and duration, and work is sometimes called effort, work and duration are not the same thing. I know in grading the last assignment, the network diagram, some of you had activities with a duration of 0.25 days. That to me, I'm sure that must mean work rather than duration. Duration is the amount of time it takes from the beginning of an activity until the end. Work is the actual amount of time spent on the activity. So work takes place within the duration. Duration is always equal to or longer than the work, assuming of course we just have one person assigned to the activity. The schedule is based not on work but on duration. Okay. Now let's see what we can learn from this particular activity. First of all, you'll notice that the very first activity is called Go Ahead, and it's a square or a diamond shape. That is a milestone. A milestone is like a place marker. Okay? A milestone does not have duration. It has no resources because there is no work. It's just like out on the highway, at least in the United States. Out on the highway, every mile, there's what's called a mile marker, which is very similar to the milestone. It just simply tells you how far you've driven. And if you're going to get off at exit 25 and you're at mile marker 10, you know you have 15 miles to go until you turn off. So this just tells us that we're at the beginning of the project. And this tells us we're at the end of the project. You can put a milestone anywhere you like. If you have a project with 3 or 4 phases, and some projects are like a design phase, a prototype phase, implementation, manufacturing, whatever it happens to be, you can put a milestone at the end of each phase. Milestones are not required, at least not usually. I've done some projects for the federal government, and they do require some milestones periodically. And those milestones are the point at which I get paid. So, of course, I'm interested in those milestones as well. But normally, the milestones are determined by the project manager, and they're for the convenience of the team to help them track the progress of the project. It's a normal convention to put a milestone at the very beginning. I've done go ahead, you could put start, begin project, whatever you want to call it. And one at the end called end project, project complete, finish, again, whatever term you'd like to use. But that simplifies things quite a bit, because you remember I said in a previous blog, every activity except the very first one has to have a successor. And every activity except the last one has to have a predecessor. So you can see that each one of these in between has both a predecessor and a successor. Now these arrows here that link the projects or the activities together are called dependencies. And up to this point, it's been very simple. When we start the project, we begin with the budget. When we finish the budget, we start the approval process. When we finish approval, we start the prototype process, and so forth. This dependency is what we call a finish to start. You finish one activity and you start the next one. Not all relationships between activities are finished to start. There are at least 3 other types of dependencies, and they're that we can use. Another one is called start to start. As soon as one activity starts, the next one can start. Let's suppose, for example, that we're installing a computer network in an office building, and the network is going to consist of 25 computers. We don't have to install all 25 computers before we start the networking. In other words, it doesn't have to be a finish to start. It could be a start to start, because as soon as we start installing computers, we can start networking. Okay? So that could be a start to start. There is also what's called a finish to finish. And it's very similar. Again, it means as soon as one activity finishes, the next one can finish. And I'll give you an example of that in just a moment. There are a couple of others. We won't worry about those. The basic ones that we need to be concerned about are finish to start to start, and finish to finish. There's also what's called lags and leads, and I'm not going to get into that too much, but this is in addition to the dependency. Let's suppose, for example, that we are building a parking lot. And so one of the activities is going to be pour concrete. And the next activity is going to be mark the parking stalls with paint. In other words, paint in the striping. That would be a finish to start, but we don't really want to start painting the striping in until the cement or the concrete has dried. And perhaps, um, well, in Baja California, it probably doesn't take very long, but up here in Washington, where it's not so hot, it might take 24 hours. So it's still finished to start, but we want to put a lag in there of, let's say, 24 hours. So as soon as the 24 hours are up, then we begin to paint the striping. Okay, that's a lag, and there are times when we want to put that into essentially what it is. It's a buffer in between two activities. And an alternative is to put a dummy task in. That is a task that takes 24 hours but has no resources assigned to it. And we can call it waiting period or buffer or whatever. That's an alternative to a lag. It has the same effect. A lead is really a negative lag. A lead is a sense that two activities overlap. So in other words, it might be a finish to start, but instead of waiting 24 hours, we start the second activity 24 hours before the predecessor has been completed. And there are occasionally situations where we might want to do something like that. Let's look at the dependencies again. We talked about the fact that there are three basic types of dependencies. So what does that really mean for us as a project manager? Well, it gives us some options. First of all, in using project management software, and it doesn't matter whether you're using Microsoft Project, Open Project, or Merlin, or any other for that matter, the default is going to be finish to start. When you create activities and you begin to link them together, the default dependency is finish to start. And that works fine for most projects. But let's suppose in this situation we have a completion deadline here that's going to be somewhere around the 10th of October. Let's suppose the boss says 10th of October is too late. We need to finish by the end of September. So essentially what we have to do is we have to take a week and a half out of the project. There is only one way to do that, and that is you have to shorten the critical path. Remember, the critical path is the longest path. The critical path determines how long the project is, because the length of the project is equal to the length of the critical path. Okay, so how do we compress or shorten the critical path? Well, here there are lots of different ways of doing it. We could look at, for example, well, do we really need a prototype? If we didn't do a prototype, we could take 6 weeks out of the project. That would solve the problem immediately. In fact, we'd finish 3 weeks ahead of schedule. Ahead of the deadline, I guess I should say, because the deadline now is 10/1, but the completion date is 10/10. We need to move the completion date to the deadline. So take out the prototype, and we're several weeks ahead of our deadline. But we have to be careful, because there's a reason why the prototype is in the project. Somebody thought it was important. So if we just randomly start taking things off the critical path and out of the project entirely, we may be causing some serious problems. Certainly it appears to me that it would increase the risk to manufacturing if we didn't have a prototype. So let's say that's not realistic. Okay? Well, another option might be to reduce the duration of some of the activities on the critical path. Now we can do whatever we want. We can say, okay, let's do the prototype in 5 weeks, and we've solved the problem. Or let's say 4 weeks. We've solved the problem. Well, we've only solved the problem if we can really do it in 4 weeks. But if we don't have the resources, then it doesn't matter what we say, we aren't going to finish it in 4 weeks. So we could hire some additional people to finish that prototype sooner. That, of course, is going to drive up the cost of the project, and if cost is a driver, then that's not an option. We could also authorize overtime so that the people who are already working on the prototype could finish it sooner. And that's sometimes a good short-term solution, although too much overtime burns people out, so we have to be careful. In most shops, overtime is time and a half, so that also drives up costs. So that may not be an option. We could also divert resources from other activities. We talked about this just a moment ago. Let's say, for example, that we've got some people working on the advertising plan who have the right skills to be able to work on the prototype. So we can take some of the people off the advertising plan, put them on the prototype, finish that in 4 weeks. We'll eat into our slack, but essentially we will be able to meet the deadline by doing that because we've shortened the critical path by diverting resources from non-critical to a critical activity. Now there's another option too that we haven't talked about, and that is everything here is finished to start. That's as I said, the default value. We sometimes call that a serial project because each activity is done one after the other after the other. But in actual fact, we can do sometimes things simultaneously. That is, two things at the same time. We can also call that concurrent. Whatever term you use, the fact is that if we overlap activities, the work can get done faster. So if we were to change the dependency, let's say, for example, that we have a situation here where manufacturing takes 12 weeks and the assembly takes 4 weeks. So that's a total of 16 weeks for manufacturing and assembly. But let's assume that we're manufacturing 4 parts simultaneously, and we're going to manufacture, I don't know, 1,000, however many thousand it is. We don't have to wait until all the parts are manufactured until we begin assembly. What we could do is we could overlap those. So if we were to change manufacturing and assembly from a finish to start to a start to start, we would be able to take out some significant time from the critical path, and then that would shorten the length of the project so that we meet our deadline. Let's try doing that real quickly, and I will select manufacturing here, and instead of, let's do that as a start to start. Now what's happened? Well, for one thing, we were going to finish out here. Now we're going to finish here. This was our deadline, end of September. We're now going to finish about the 12th of September. So we're about 3 weeks in front of our deadline. So that's a great solution by overlapping those, right? Notice also that we have altered the critical path. By definition, the critical path is the longest path. Now what's happened is by overlapping those two activities, the critical path is shorter and we have a new critical path. But have we really solved the problem? Not actually. Here's the problem. By changing manufacturing and assembly to a start to start, it's true we did move up the completion date, but we're going to finish assembly before we finish manufacturing. Now, my background's not manufacturing, but I'm guessing that that's not likely to happen. It would seem from a logical perspective that you can't assemble things that haven't been manufactured. So this solution is not going to work, which is too bad because otherwise it looks pretty good. Do we have another option? The answer is yes, we do. And that is where we could change this from a start to start to a finish to finish. And now assembly finishes at the same time as manufacturing. This is now a workable schedule. But notice also what happened. We didn't change the critical path, but we actually have 3 critical paths in one project. 3 of our 4 paths are critical. As a project manager, do we like critical activities? Think about it for a minute. Every critical activity is an opportunity to delay the completion of the project, because if a critical activity doesn't finish on time, it's going to delay the completion of the project. So by adding more critical activities to the project, there are more opportunities to finish late. In fact, there are only 3 activities in the entire project where there's any slack. We have essentially taken all of the slack out of the project except for right here. And that gives us a lot less flexibility. So, like everything in project management, there are trade-offs. I would be tempted to go with this solution because even if we don't finish on time, our schedule says we're going to finish 3 weeks before our deadline. So even if we slip a week or 2 or even 3, we'll still make our deadline. But this is a schedule that's going to be very difficult to meet. Not impossible, but difficult, just simply because of the number of critical activities. There are a couple of other things I want to cover this morning. One is the idea of constraints. In scheduling, we have the dependencies. And by manipulating dependencies, as you just saw, by finish to start, start to start, or finish to finish, by manipulating those dependencies, we can play around with the schedule until we find something that works for us. We can also refine the schedule a little bit with things like lags and leads that I talked about a moment ago. There's one other element that allows us to some flexibility in terms of scheduling, and that's what's called constraints. I think I've got a graphic here that shows some of the constraints. This is from the supplemental reading. This is a table showing the scheduling constraints. Now don't confuse these with the triple constraints of time, cost, and scope. These are scheduling constraints. And you may be familiar with some of these. I think the term ASAP is something that most people are familiar with, as soon as possible. Just as when you're using software, the default is finish to start for dependencies, the default for constraints is as soon as possible. In other words, if you have a finish to start, the default would be as soon as possible. So when you finish one, as soon as possible, you start the next one. Okay. We also have one called as late as possible. Now, first of all, if there's no slack, as soon as possible and as late as possible are the same. As soon as possible means that you start immediately, as soon as possible. As late as possible means that you can use slack, and at the end of the slack period, you begin the next activity, assuming it's finished to start. Are there times when you would like to use as late as possible? Well, obviously there are, or we wouldn't be talking about it. Let's say, for example, well, in fact, I was working on a project where This happened to have been a construction project. We had purchased some building materials. We wanted them delivered as late as possible. Why as late as possible? Well, we didn't have any place to store them. We wanted to be able to get them just as we needed them, kind of a just-in-time situation, because we didn't have the storage space. So that's one of those situations where we would use as late as possible. Let's go back to our example here. Let's see if I can. Okay, we're back to our original situation here. Let's suppose, for example, that produce TV ad. Let's say we wanted to do that as late as possible because we wanted in our TV ad we wanted to show the delivery, for example. So this is a bit of a contrived example, but I'm sure you can think of something that's perhaps more realistic. But we wanted to do the TV ad as late as possible. Okay? Well, as soon as possible would be here, which is in June. As late as possible, let's see where that might be. Okay, and I want to start this as late as possible. And let's see what's happened. Now we have to start it in middle of August. What happened here? Well, what we've done is we've essentially taken the slack that came after producing the TV ad and we put it before. So this slack is all used up. And when you have no slack, you have essentially what? A critical activity. That's why this is now red. Okay? There's no slack. And so now, if producing the TV ad takes longer than 8 weeks, we delay the completion of the project. So we're able to include the most recent events in the TV ad, but there's a price to pay, and that is it now becomes a critical activity. So here again, there's a trade-off. Is it worth it? Well, perhaps it is, perhaps it isn't. But the fact is that creating critical activities is something that as a project manager, I'm not real eager to do unless there's a really good explanation for it. So we'll go and undo that. Okay, let's go back. Start no earlier than, start no later than, finish no earlier than, and finish no later than. These are all dates. You'll notice in terms of flexibility, these two, as soon as possible, as late as possible, give you the maximum flexibility. Start no earlier than, let's say start no earlier than June 1st, gives me no flexibility before June 1st, but I have a lot of flexibility after June 1st. So all of these give me some moderate amount of flexibility. Why would you want to use these? Well, let me give you an example. I was a project manager for a conference. It was done each year the first week of December. The project began in January with the planning. As soon as we had contracted with the conference center, there were all kinds of things that we could do. We could begin contacting speakers. We could determine the menu for the meals and the breakout sessions. I mean, there were all kinds of things that could be done. So if you were to look at a graph of activity, it would show that we were extremely busy in January when we signed the contract with the conference center, and with each successive month the amount of activity would go down until about end of August, early September, when the activity level would start to go back up again. And as we got into October and November, the activity level was extremely high. So essentially we had a situation where people were working extremely hard in January and November and not quite so hard in between. Well, wouldn't it be nice if we could spread that work out a little bit so that people weren't exhausting themselves in January and November and could spread that work out. Well, that's essentially what these do. Um, as soon as we sign the contract in January, we can order the meals for the banquet, which is first week of December. Well, couldn't we say start no earlier than November 1st? That gives us a whole month to schedule the meals and the breakout snacks and so forth. So by specifying various dates, we can spread the work out a little bit so that we have a more even workload. We can also use this to alleviate resource conflicts. Let's say somebody's going to be on vacation until let's say June 1st. So we can say start this activity no earlier than June 1st because that's when our resource will be back from vacation. So these are all things that again we don't use unless we have a specific purpose for it, but they can be very useful in helping us tweak our schedules so that it will work for us. The last two are must start on and must finish on. These are in red because you shouldn't use them unless you have a very, very specific reason for doing so. These are the least flexible of all the constraints. There are times, however, when you want to use them. Let's say, for example, that you need a particular piece of equipment for the project, and you're going to lease that equipment from a local vendor. You're going to need it on March 10th. It doesn't do any good to get the piece of equipment on March 6th or March 12th when you need it on March 10th. So that activity, or let's say the equipment's only available on March 10th, then the activity must start or must finish, depending on the duration, on March 10th. So there are situations where you do want to specify a date. But for the most part, we don't specify dates. And this is the nice thing about project management software, is essentially, for most projects, all I have to do is put in a start date, and the computer calculates all the rest of the dates. Unless I've used one of these constraints, it calculates all the dates. And what's really nice about that is that if the boss comes to me and said, we're not ready to start, we're going to have to delay the start of the project for a week, I only have to change one date. Everything else throughout the entire project is automatically updated. Although, if you have set specific dates by using these constraints, the software will not override those dates. You'll have to go in and manually change these dates. Okay? So that's another reason why we should use them sparingly, is it adds additional work to the management of the project. Well, I've talked about software. I know that some of you have access to Microsoft Project, and some of you I know have used Open Project. Open Project is really nice in that it has one particularly appealing feature, and that is that it's free. It doesn't cost anything. You can download it from the internet at no cost. It operates very, very similar to Microsoft Project. So if you're familiar with Project, Open Project is pretty easy to use. If you're using a Mac, you can also use Open Project, or you can use Merlin. The Merlin demo will allow up to 40 items. So if you have a small project and you have a Mac and you don't own Merlin, you can use it. Otherwise, you'll have to use Open Project. This is not a course on how to use software, but I did want to just give you a real quick introduction to open project. I don't use it myself, so you'll have to bear with me just a little bit. But here we have open project. I've just created a new empty project, and I can go ahead and click in there. It turns black, which to me doesn't seem like a good design feature, but let's put in start project. That's our milestone, right? And now if I click in the next box, you can see, oops, helps if I can spell right. There we go, start project. Now remember, start project is a milestone. And milestones don't have duration, but this appears to have a duration of 1 day. If I double click on this, it brings up a window, and this is called task information. And I can go ahead and you'll see there's a number of tabs here. The duration is by default 1 day. You'll notice that there's a question mark after the day. The reason why there's a question mark is to indicate that it's an estimate. I've never really quite understood why that was necessary, because when you're planning a project, every duration is an estimate. But apparently that's to further emphasize the fact that you're not sure how long it's going to take, but that's your best guess. If you click on the estimated box, it takes that out. I don't care whether you take it out or leave it in. Percent complete, we're not going to worry about, because that's not planning the project, that's in tracking the project, and that's beyond the scope of our class. Here's the start date. Again, I wouldn't, and the finish date. I wouldn't mess with that. You can change the duration. Let's change that to 3 days and see what happens. That does change the date. Predecessors, we can, now this won't have a predecessor, and it can't have a successor because there is no successor yet. But this is where we would put them, the predecessor and the successor. We aren't going to worry about resources at this point. The advanced here, this says display task as milestone, that checkbox. I'm going to check that, and you will notice now that going from a bar with a duration of 3 days, it goes to a diamond. And let's go back to general. It still says 3 days, but in actual fact what happens is that it's ignoring the duration, because milestones don't have a duration. And is there anything else in here? You may have to put the WBS in here. Here again is your as soon as possible, latest, all that, the constraints that we just talked about. And let's see, where else do we have our... Oh, when we put in our predecessors, this will give us the type. Let's go ahead and do this. Let's put activity 1. Okay, let's put in and let's put in here I've forgotten how to do this here. This is our activity, and we need to add a predecessor here. It's been a while since I've used this, so let's see here. I'll cheat a little bit here. If I select these two, I think what I can do is, there should be a chain up here. There we go. You see that chain that links them together? Now, oh, I know, I needed to select both of them. That's what I did wrong. Okay, so now you can see there's activity 1. It's a finish to start, but I can change that to a start to start. If I close that, now you can see how this is a start to start. Okay, that's probably most of what you need to do in order to do the assignment. Obviously, Open Project can do a whole lot of other things, but if you can master those minimal skills, you should be able to do the assignment without any difficulty. So there are, I believe, online some manuals, user manuals for Open Project. You might want to check those out, but it's fairly simple and straightforward. So, not sure that it's really necessary. Well, I think we've covered pretty much what we need to cover. Um, don't forget to read the grading rubric. I'll have to check and make sure that I've uploaded it. And if you do all the things that we've talked about here today, you should do well. So good luck on this assignment, and we'll talk to you later.